Hello, and welcome to my channel. I would like to kick off this channel with a series of challenges. In this first challenge, you will simply download or utilize an online planetarium type application, learn the basics of using it, then compare what it displays to what you observe in the real world. My hope is that we can establish a baseline that validates or perhaps invalidates these applications as a reasonable tool to serve as a way to talk about the movement of objects in the observable universe. The first challenge for you will be simple. Locate and utilize the Solar System Scope software and learn the basic controls. For this video, I will be utilizing the online version of Solar System Scope available when you simply go to the Solar System Scope website. If you believe that the representation of the information provided by the software is incorrect, this is your opportunity to demonstrate it to be in error by pointing out the discrepancies in the comment section of this video. Next, I will demonstrate the basics of how to confirm that it is, in fact, displaying accurate information. First, we're going to go to the website solarsystemscope.com. Once you're there, click Start, and once that loads, click the screen to run the model. Realize that objects depicted are not to scale, otherwise many of them would be too small to see. This feature is changeable by going to the configuration page and changing sizes from large to realistic. Once it loads, double-click on Earth to select it, then click on Night Sky to land on Earth. From here, you can explore celestial objects. Click on the geo icon and make sure the location is near your actual location. You can click anywhere on the map to relocate yourself, or click on Find My Location. Once you do that, locate Polaris, the North Star. It will be almost directly north and at an elevation angle that is at your location's latitude. You can turn on the option to display the names of the major stars. You can also search for stars by name. For this example, I chose Polaris because of its consistent location in the sky. Also in the setup screen, scroll towards the bottom and turn on the azimuthal grid. The azimuthal grid draws grid lines representing elevations and azimuths from your perspective. So for instance, the horizon will be 0 degrees and directly above you will be 90 degrees. You can use this to determine, for instance, the elevation angle of Polaris in the night sky from your geographical location. In my case, since Kansas is at latitude 37 north and 41 minutes, I should be able to observe Polaris at about 37 to 38 degrees elevation, which is what happens if I go outside and find it in the night sky. You can change the observing location and watch how the position of Polaris changes from straight above you if you are on the North Pole, or at the horizon if you're near the equator. For the purposes of this first challenge, if you live south of the equator, you will have to use objects that are visible to you, since Polaris is below your horizon. You can also observe how celestial objects move over time by hitting the play button and sliding the speed control left and right. This first challenge is for you to explore this or a similar program and confirm that the objects depicted in the software for your location and time do indeed align with what you see in reality. Objects like Polaris, the Moon, and the Sun should appear in the direction and elevation depicted in the software. If you are using a compass to determine the direction outside, remember that there might be a variation factor between true north, which the software utilizes, and magnetic north, which your compass uses, and this discrepancy varies depending on your location. Just seeing Polaris in the north sky at the elevation angle predicted is enough for this challenge. If you find inconsistencies, or even if reality confirms the application, I would love to hear from you in the comment section. Please mention your location, the time, and the object that you are observing, and the amount of error, if any, that you observed. In the next video, if we have confirmed that this type of software does indeed match up with what we see in reality, we will talk about the next challenge, which will attempt to determine the distance to some of the objects that we can see in the sky. Until then, I would appreciate any comments, likes, even dislikes, and especially your subscription. Until next time, goodbye.